Hi everyone, thanks for joining. Um, I think today's topic is the next hop member group member list. So Kishore, do you want to go ahead and share your screen?
Sure. Can you hear me?
Yeah. Okay.
Okay. All right. Let me share the PR. All right. Can you see my screen?
Yeah.
Okay. Should I get started, or are we waiting for more people?
Uh, I think you can go ahead. Yeah, we have enough of group.
All right. So this is uh, the PR where we are introducing a new type of next hop group. And before going into the changes, I just wanted to go over like motivation behind this. So we've seen that, when there are like network events, like a switch going down or a link down, leads to a lot of forwarding entries being updated across the network. And we were looking to improve the convergence time. And we found that next hop group changes were playing a significant role in this convergence time. We deep dived into the site, workflow for creation and updating of next hop groups. And so the existing workflow to create next hop groups is you first create the next hop group, and then you start adding next hops to this group. And to modify next hop groups, uh, the org agent is doing some kind of a comparison with the current state and the desired state. And based on this, it can, remove stale next hops. It can modify attributes of existing next hops, which are common to both the current state and the desired state. And it could add, new next hops, which, are now kind of viable for this next hop group. And one observation was that the application would have to do some kind of, you know, uh, uh, sequencing to ensure that the next hop group is not, exceeding the maximum size. It's never empty, you know, at any time. Uh, and with the constructs we have of removing next hop members, modifying and adding, these are three separate uh, SCI API calls. Bulking does help here, but still we could end up in a state where we need to, you know, uh, need three calls to get to the desired state, and in between the group is in like, an intermediate state, uh, and maybe in a suboptimal state in terms of like how much throughput it provides and things like that. So based on this, intuition, we uh, looked at the possibility of specifying the desired state in one step. So if we could specify the list of next hops we want and their corresponding weights, uh, we could achieve the modification in one step. So the proposal is to introduce a new type of next hop group, and we would introduce two new attributes. One would be the list of next hops, and the other attribute would be the list of weights. And when we create the next hop group or we modify the next hop group, we specify both of these lists. Another point to note is there would not be any next hop group member objects created in this workflow, which was like what the, the create next hop group member API, the current API does. So modification of individual member would need the application to, pass in the modified list of next hops and their corresponding weights. So here is an example. Let me do the render it. So here is an example of creating a next hop group. You have three next hops, NH1, 2, 3, their weights in the same order. And you would set the next hop group attribute type to this new type. You would specify, the wait list and the next hop list, and you would create it. Modification of that next hop to, let's say, NH, you had NH1, 2, 3, now you're going 1, 3, 4. So you would specify the desired state. So the entire list of next hops in your desired configuration is what the application would provide, instead of trying to do a difference between the two states. So it's Orc Agent's processing is much simplified in this scenario. And you would do a bulk set on this next hop group. These are the changes that we are making to the next hop group header file. So there is a new next hop group type, ECMP with members. We were the spec would originally, allow you to read back the current next hop member list, which is no longer valid here. It was returning a object list of type, next hop group member. We are not maintaining that kind of object anymore. The two the two attributes that we are, using to pass the next hops and their weights are next hop group attribute, next hop list, and next hop member weight list. And we are also, adding the ability to bulk set attributes on the next hop group. So we see that this is like, something which exists alongside the current workflow. So you would either use this workflow to create and modify next hop groups or the existing workflow, but you would never use one API to create and another API to modify. So they will just be two parallel independent workflows. So that's the proposal in a nutshell. If there are any questions, I'm happy to take them now.
Kishore, this is Ravi. Yeah.
Go ahead, Ravi.
Yeah. Kishore, this is Ravi from Marvel. Okay, one question I wanted to know is, right, see, I understand the proposal, but one thing I find it odd is the weights is a property of the next top member. Okay. I think I had a comment out there in a conversation.
Yeah. So I think
see, the problem what I see is, right, Kishore, what we have done is the weight, which is a proper next top member property, right? We have made it two separate lists two separate attributes, which are lists of the next top group object. Okay, so now what's happening is, right, so this whatever we have done will solve weighted ECMP case, but tomorrow when we want to solve the fine-grained ECMP case, right, we would again come up with a new list. And it's become little, yeah.
Fine-grained, we don't quite see the use case for that. So we're not addressing it at this time, but if you consider that the application is providing the entire list of next hops, right? So it is providing it in the order that it desires. So it's already ordered, is what I'm trying to say. Because earlier, what would happen? The use case for ordered was there could be multiple switches in a Clo layer, and if they got the same, next hop group programmed, would they all behave the same in terms of which members they picked, right? So each switch could have added the members in different order. Like you could have, let's say a next hop group with members A, B, C, D. Now, if you add B before A, potentially in hardware, the ordering may be, may be different, right? But now that in this paradigm, we are giving you the full list of next hops, A, B, C, D in one shot, right? The expectation is that silicon from the same vendor, same generation will do the same thing.
Kishore,
Okay, good. Yeah, I think let me finish this conversation. Kishore, I think what is happening is we are assuming, okay, let's say for some cases, what you're saying is instead of specifically giving out the sequence ID, assume what are the orders passed, that's the ID, right?
Yes.
The problem is all this is piecemeal, right? Today we have, there could be other features. For example, right, I need to have a per counter per next top group member today, which is supported for the other use case, right? If we want to support for this ECMP group, this next top group, how much packets went out on each next top, okay, each member next top, right? For that, let's say there's an attribute. Today there is an attribute called next top group member counter. Okay, so now how do we get this, right? The moment, what is the next top group member property? We are trying to flatten it out into the parent, right? All of this becomes a problem.
So the issue or what we found with the next hop group member object is that you need to, create next hop group member call to create it. So that is the way that you add a next hop to a group, and that gives you back this next hop group member object, right? That you can later, use for removing that member or modifying its property. So that, that whole workflow, like I described, would make your modification always, a sequence of creates, modifies, and removes. So it will make it, in the worst case, a 3-step, modification.
Kishore, I understood that use case, right? But what I'm not happy, what I think is not a clean, scalable way is to the way we have modeled this as two separate lists. Instead, I was just thinking out loud, right? I could create, let's say, whatever is there today, it's I next top group member. When I create that object, let's say I make the next top group ID not mandatory. Okay, so at this point in time, I can do a bulk creator. I create a set of next top group members, and here I'll be passing what is the weight, all this information, right? For the text top, I'll send all this information. Okay, and then this next top, I could, when I next create a next top group, and during the create next top group, I can pass this list of list of all the member next stops. So this still can be done in 2 operations.
So Ravi, we looked at, doing some kind of a, struct for grouping these attributes.
Okay.
But what we found was the meta checker, whenever it sees a complex type like an object ID in a struct, it needs that struct to also be an object. So,
And okay, yeah, go ahead.
so what you're proposing, I mean, I just looked at it this morning. I haven't gotten a chance to fully work through the details. But if you're saying, okay, I'm going to remove only the next hop ID from the current next hop group member and leave other attributes like what you mentioned, counter, for example, right? Counter object. So that is an OID. So this struct would need to,
Become an object type.
become an object. So what we are facing is this 2-step thing, like create an object. That's gonna, lead us away from this one-step modification, which is key for our requirement. So as you're saying, right now I have 2 lists, one a list of next hop IDs and another list of weights. If you want counters, there will be a corresponding list of counters. So that is a fair point. But passing all of these in one shot is, I mean, something we were looking for, and this is like one of the ways we found. So
Kishore, maybe I'm not following in the sense, right? Even with this new model, right? Let's say we have to create another object for the next top group member. Okay. But what it means is it will avoid all the intermediate steps. When we create this new type of next top group member, where I give the next top information, but not the group ID information. Okay.
But Ravi, like the application has to do this, right? So it will create these, let's say, properties of the next hop group member, right? But it doesn't do anything in hardware.
Yes.
So the application has to first create these. When the SI adapter replies to this operation, then only it can use these to create the next hop group or modify it, right? It's still a 2-step process.
Okay.
And I fully don't understand how you will bind each of these objects with the next hop ID, because that part maybe needs to be worked out. But again, like the ask from our application, which reacts to topology changes and generates a lot of these next hop group updates. So let's say a link flapped in some switch in the network, it leads to like a cascading effect across. So all the switches start updating their next hop groups. Until they are all done, we cannot claim that we are converged. So we are looking at doing this, without having multiple round trips between the orc agent and the SIG SI layer, and and also do it in a bulk manner, so that you can just send one bulk set on all the next hop groups, and it will just be one round trip between orc agent and SIG, and you're converged, right? So
okay, I got what you're saying. So what you're saying is, right, the moment you make one orc agent, one SI redis call, you're waiting for the response before you can proceed with the the next call.
yeah, it's a dependent the dependent objects need to be, installed.
Created first.
And,
Yeah.
yeah.
Okay. The only thing, we are making two flat lists, right? It's maybe for this use case it works well, but tomorrow if I have to just go remove one next stop, right?
Yeah, so the removal of one next hop is, the application will now have to prune like the current
entire
next
list,
hop
yeah.
list and pass the new list and the new weights.
Weights, yeah. The problem is always I have to do both of them together atomically. Because
so
I always want both to be of the same size, right? Both the lists should always be the same size. And
that's fair. I mean, so just for pruning one next hop, maybe this is some overhead, but for the general use case where you're modifying a group with many creations or many modifications, many removals, then you have kind of collapsed it into one bulk set.
one
So
bulk set call. Okay.
yeah, that's the use case we are wanting to
Okay.
address.
Okay. Okay.
Yeah,
Yeah. Anand,
yeah, Ravi, I think the point you're raising, the bigger question is, how does the NOS know that all the updates are done for a given next stop group? Right? I mean, that's a bigger question. Is there an end of update flag? Typically, when the churn happens in the network, it's non-deterministic. The updates are non-deterministic. So Kishore, I mean, that's a question for you. How do you know that, yes, all the updates are, completed, and now you're going to trigger a
So for us, we are, our use case is like the centralized controller, right? The SDN use case. So they, when they get topology updates on some network, link going down or the switch going down, they will compute the goal state, the target state for all of these switches, and they send actually the modified or the updated list to the switches. So what Orc Agent today does is it's getting the full list, the new list. It has the current state that's programmed in hardware, and it's doing a delta and trying to do this create, modify, remove. So it's trying to tease out the change into psi operations, whereas it already knows the new list.
You're right, Isaac. I think once it goes to Orc Agent, that part is fairly understood.
Okay.
But I think we have, see, the discussion can be looked at it two ways, that either you do the deferred processing in the psi, wait for all the updates to come, and then you create a one consolidated update down in the hardware, right? And as you rightly pointed out, that has a bunch of problems. So we bubbled up the problem up, and the question still remains, right? As for your SDN controller, I really don't know the implementation, but we can make argument. But will that be true for Sonic as well? Basic question remains, right? How does a control plane entity knows that all the links which were flapped, right, associated next hops have been stabilized, and it's time to invoke the Orc agent? That's something which which basically is a non-trivial either way. Somewhere we have to solve that problem.
Yeah, I mean that's a good point. I would have to check how other use cases like BGP and handle this, right? So I would think that they would also have computed the full state for a given next hop group.
BGP,
And
BGP works a little bit differently. BGP will get for any remote BGP peer, you will get for a given AFI-SAFI an update, and that will have a full summary update, but it's for a given endpoint, right? But you may have multiple endpoints, especially multipathing when happens, and it goes through the same convergence process, and you may have intermediate states. Basically, what I'm saying, if you can provide a guidance that a given implementation, if it's using this, then what's expected from control plane?
Yeah, I will check what is the AppDB schema for next hop groups. I think it's the list of members, right? So as long as that is provided, in both the paradigms, uh, uh, it should work as it works today. It's just uh, potentially you're converging faster in one way, whereas the other way maybe is more optimal for one, two kind of next hop changing at a time.
Right. Yeah. No, I think I mean I see the reasoning of the proposal that makes sense to me, but the point Ravi is raising also are valid, and I feel that's more of a control plane question because we agreed that okay, we are gonna push up the processing, right? But that's again, it's just a guidance. What a given implementation should do from a control plane point of view.
Yeah, sure, that makes sense.
Other question I had that now we have two methods in the. Sorry, Ravi, I interrupted you.
No, go ahead. I think Anandi had something, but go ahead, Jay. After this, maybe Anandi can ask.
No, I think the more obvious question was that we have two implementations in the SI. How do we do the capability? Is that you have captured somewhere? Which adapter is supporting which method?
Yeah, I think
Jay, I think since there's a new enum created for this type, right? I think the SI adapter, we can just do attribute enum capability query to get this. But Kishore, it will be good to update it. I think you just need to
Yeah,
you don't
yeah.
have any SI address changes, but yeah, you can just update, right? You can use that SI attribute enum capability query on the
Sure.
new type, next up group type you have created, right? That
correct. Yeah. So I think that was my second comment. I think that's pretty much it.
Anandi, I thought I interpret you in the main. Sorry.
Yeah. Kishore, I'm just thinking the other way, like rather than introducing a new next up group type, can't we play around with the APIs? I understand the motivation. So like I'm just thinking out loud, introducing an API like create next up group with members. So where you can feed in all the data that you want to route in one shot. So that way, this problem can be addressed to all the existing next up group types also, right?
So you're saying if I can go to
Your motivation is valid. You're trying to
right.
solve it for only one group type, next up group type. Instead, if we can give a common method which will solve the similar problem for all the next up group types, that's my line of thought. So can we play, instead of playing with this enum, can we play with the APIs, like create an next up group with members, something like that, where you want to give all the next hops data also in one shot?
And if I understand what you're saying, we have this Psi next hop group API that's defined, and this is basically is a CRUD. It contains CRUD methods for each, let's say, object, right?
Yeah.
So are you saying enhance this to
Yeah.
have?
So introduce a new API like create next up group with the members. today it is a two-step process, right? You create a next job group, set the attributes, and then add the members. So add a new API, which will create the next job group and also add the members that you're providing as a list in one shot.
And the problem, Anandi, is right. This doesn't follow the CRUD semantics inside, right? Now the challenge would be, if you have to create the next job group member, okay, how do you specify the attributes, right? You have to pass the attribute list that we pass has to be one attribute list for one the parent object, the other attribute list of attributes lists, right, for each of the child object. Okay. So how do you make it generic? And for example, some questions remain, right? If I have to today, the next job group member object in turn has a mandatory parameter saying what's the next job group ID to which it belongs. Okay. So there's a dependency, right, between. So now the moment we do all this, right, will that API look like a CRUD API is the question.
Okay.
The API might become complex without structure. That's what I'm thinking. But maybe we can think more of it on it.
Yeah. But the motivation is valid, but trying to solve it for a specific type, that's my thought. What we can do to give a generic thing without much backward compatibility issues.
Yeah. I think with the current proposal, I think that's what Kishore was saying, right? The problem with the current proposal is if you want to add new use cases, we start creating more more attributes in the SI next top group with the type as list. We flatten it all and make more list things, right? Whatever. For example, if you want to create, let's say you want to do the same thing for consistent ECMP, for fine-grained ECMP, right? Then we will have to introduce a new type called ECMP group, a new enum saying.
That will become clumsy, right? That will become clumsy.
I think fine-grained ECMP use case we are not targeting here, because that is more like, you have full control on where in I mean, you have this abstraction that this is like a block of memory, right? And some next hops can be updated to point to, viable members if some links have gone down, right? So that use case we are not targeting with this proposal. I mean,
Sure, but the same semantics, right? Same thing applies. The same problem statement what you made, right, applies to fine-grained ECMP as well. Even though it's a block, and if some members go down,
then I mean, I haven't gone thinking through how that would work. But if if that full block of members can be re-specified in exactly the order that the application wants, then that is one conceivable way of addressing that use case as well. There won't be any holes in that contiguous block of memory, right? So you have to specify all the members. So potentially, you could use that, but I'm not advocating that we will support it for the fine-grained case as well. We only have the weighted case in our mind, and we're trying to
agreed that that's the use case you need to solve. But I think on this point is right. Whatever model we are trying to do, it should be extensible to the other use cases, right? I think that's.
I mean, some of the use cases, like I believe a cost-based ECMP was added, into the spec recently. So we don't have any kind of, we have not thought about how would it apply there, right?
Okay.
So I think it's fine to, just say not supported or, something along those lines, but not all silicons will support all the types of, ECMP groups that are there, right? So this is
Sure, I
a
think this is point, right? This is a point of agreed, right? We are working on a current silicon where ECMP with members are supported, and we are doing this. But tomorrow, for somebody else, not your use case, but for somebody else, right? We need to support the same use case for, let's say, weighted fine-grained ECMP or ordered ECMP, right? Then they don't
right.
need to have to do something different.
So Ravi, if fine-grained ECMP is supported by next hop group member API, right? Then as opposed to, doing point adds of the members, if you get the full list, will the SDK not accept it? That's a question for the vendors. I'm not from the vendor side, so I cannot answer that.
Yeah.
I can just assume that if the SDK allows you to add point members and it allows you to add the full list, then you have two ways of solving the same problem. So adding with the full list is what this new next hop group type, gives you the option. I mean, that option is not there today, even if the SDK supports it. This exposes that capability.
That's the point, Kishore. Exactly right. Let's say the SDK device supports it, right? And I think it will all support. The device can support incremental changes. If you give the entire list together, the SDK would support it, right? It's a subset of the functionality what they would already support. The question here is, let's say, if we want to enable this functionality, whatever we have done, this infrastructure for fine-grained ECMP, okay, then what all needs to happen? Somebody again has now go create a new enum here saying that SI next top group type ECMP fine-grained ECMP with members.
No, I think
a lot of things.
These existing list of next hops and list of weights may just apply. I mean, I haven't analyzed the implementation of fine grained. The only thing is the weights would all be equal to 1. I think that's how fine grained is currently set up. But yeah, if you specify the full list of members, there is a chance it could work, but that's not something we are, targeting or validating. So yeah, that's kind of.
Okay. Okay, Kishore,
Where
what?
I'm at.
Yeah. See, what I was trying. The two things, right? Either use this new enum type, maybe just making one more small change, right? So instead of reusing this next top group type, let the next top group type be there as is, and create another attribute which says you're creating it with members or without members. Why I'm saying that, right, Kishore? That way, the way we specify whether this ECMP is for ordered ECMP or fine-grained ECMP, okay, all this remains the same. And instead, we'll have another attribute of the next top group, which will say, hey, whether this next top is going to be created with members or without members. And only when this attribute with members is true, we will use the next top group, next top member list, whatever new attributes you added, right? That will be valid only when the new attribute says this is next top group create with members, right? That is true.
Yeah, I think I see what you're saying. So, but I wouldn't be able to say like, does it does that attribute apply to, let's say, protection next hop group or class-based next hop group? So it's basically, we are trying to pass that signal somehow, right? And how are we doing that? Is it explicitly via, a new type of group, and then you have these kind of valid only on this group checks? Or is it like, as you said, a new next hop group attribute which says with members, and then you say, okay, valid only if that is true. It's
Kishore, what that helps is, right, it doesn't need every time. So let's say I'm creating a new ECMP type next in the future, right? I don't have to make two entries in this enum next top group type. One says this enum, okay, let's say ECMP new type ECMP, right? ECMP XYZ. I don't need to go create two enums saying next top group type ECMP XYZ, next top group type ECMP XYZ with members. So I think instead of doing that, two independent properties should be two independent properties. Today we are flattening two properties into one enum type.
This is Guy for Marvel. I have a more basic question, if I may. What you're trying to achieve is to set all the members at once, right? Instead of adding another member and another member, right? Kishore, is that correct?
yeah, that's right.
Isn't that? I always thought that the bulk functionality is exactly that. That I can give a bulk. For example, in this case, I can give a bulk of next stop members, right? And then I expect, the vendor specific to say, if he knows how to support a bulk, he will take all those, create an internal list and apply it once, right? And if he doesn't know how to support a bulk, he will add one by one.
No, it's, I think, Guy, we were discussing this in the beginning when going over like why this, what motivated this change, right? So you're right, bulk, an optimal bulk implementation should also like do something like this, right? It will fetch what is currently programmed and then add these newly created members and program it back, right? Something like that, like a read, modify, write. But you're doing three steps here. So the bulk today supports either a bulk create, a bulk set, or a bulk remove. So there are still three operations, and the org agent, like, has to wait for each to succeed before going to the next step. So it's still not one step. So it's still like, in the worst case, it's 3 times the processing.
But the group members, you still need to. Okay, I think, but you don't need to do create and set, right? It's in create you can put the attributes of weight, right? It's not.
No. When I say set, like if you look at like an example, like you had, you started with 3 next hops, 1, 2, 3, right?
Right.
Then you modified it to 1, 3, and 4.
Okay.
So you are changing the weight of NH3 from 1 to 2. You're adding NH4, NH1 remains, but you get the picture. So when you're
you want to do like a delete all and set all. You want to do replace list. That's what, right? That's what you actually want.
SDK can do it in whichever way it wants, but we are at least providing the SCI adapter with the full list in one step.
Okay.
But you can't do the full list. You can create a new next group with all the members and weights that you intend to, and then point a route to that next group. If you want to do it.
Yeah, that's like, but what if you have
Kishore,
a lot of routes? That's it's gonna be it's gonna lead to even more conversions
exactly
time hit. So
if you have a million routes pointing to do, you have to do a million updates.
Yeah, but if you're talking about like that's depending on the depending on the control plane implementation again, because that's what Orcasian does.
And
Yeah.
also the next hop group table space is also like, you know, valuable resource. So every time you do an MBB, it leads to some of those considerations. So this is
So are you claiming that for your entire, well, let's say you have a large routing table and a large portion of it is pointing to a particular next subgroup, and there would be a lot of updates. So are you claiming that all of those routes will simultaneously be updated to the new configuration from the control plane point of view? Because what I've observed, and that's why we were adding stuff to BGP to actually enhance how BGP behaves and how it interacts with Sonic, was to do the opposite, because currently the default behavior of SPM syncd in Sonic is that each route has, as you mentioned earlier, has just a list of next hops with their weights. And in case something changes, it changes for one route, and you cannot correlate with the other routes. Are you saying that you will do this update for all of them somehow, so that you can now be safe updating a next hop group for all the routes that are pointing to it?
so, Marian, I didn't quite fully get the question, but imagine
you
that
have, you have multiple routes pointing to an next hop group, and then
yes,
something happens to an next hop.
yes.
Protocols like BGP usually update one by one, and you will be in that intermediate state that some of the routes are pointing to a new state of the next subgroup, some of them are still pointing to the old one, and you need to do these updates one by one anyway.
So in our like workflow, the route updates, if they're pointing to a next hop group, let's say there's 1,000 routes pointing to a next hop group, and one of the members in the next hop group, either their weight changed, they've got pruned. So we don't expect to see route updates happening. We just expect the next hop group to be modified.
Yeah, but
And
you would need to add support for that in the control plane, because currently it's not like that. And by the way, your case would be having issues if you have large number of next hop groups compared to the number of routes, if I understand correctly. So that you suffer when you update next hop groups.
I mean, typically the route scale is much higher than next hop group scale. So we in this topology changes.
Member updates is actually your bottleneck, even with current APIs.
So,
Yeah.
Kishore, if I may interject, if I understand the problem, it's basically a convergence problem, right?
Yeah.
And you rightly pointed out that today BGP, the way it converges is not a one shot; it's an incremental convergence, right? So that's a fair point. I think for Google's use case, and that's what earlier I was talking about, the control plane interaction. They have a deterministic behavior. I don't know how, but they know that, okay, network has converged into this new state. And when this new state is achieved by the control plane, they have all the information regarding the next hop, and they want to do a one-shot update instead of this incremental update, so that the data plane converges fast, right? So So, and then other side effect of doing the incremental update besides convergence is also they start seeing the scale limitations, because now they have to create the new next hop group without deleting the members, without deleting the other ones, right? So that's another side effect. Kishore, tell me so far if my understanding is correct.
But you can modify in place. If you have the final state, you can just modify a group in place. You don't need
I
to.
mean, that workflow, I think, with the bulk Kishore has pointed out, and I agree that there are still 3 steps, which means that you have to pass the control plane and the data plane 3 iterations, right?
Maybe I didn't understand what those 3 iterations are. Can we?
Right.
Can we go
So
over them
Marian,
again?
if there is like let me see if there's some way I can.
This is a well-known problem, this convergence, and a lot of other NOSes, right, like Cisco, Juniper, they do this one-shot up. They provide this ability to do one-shot updates.
So yeah, so Marian, this is an example where can you see the slide? So essentially, you have but this is 3 next hops. You start with ABC. You want to go to C, D, E, F, right? So the first step, you're gonna get rid of A and B. Next, you're gonna update C's weight to 2. And then finally, you're going to add the new DEF, right? So in this, we assume that.
Okay, so you have E and F, which is not A and B. That's why you have 3 operations. Okay, got it.
So we see that, yeah, you if it is a pure group expansion or pure pruning, then it's just bulk creates or bulk removes. But if you have these 3, then
but is this really like, okay, now it's now it's kind of interesting. Is this really the case that you will have at the same time some next hops completely removed and entirely new next hops added? Is that like how drastic the reconvergence is, like that you end up with a different set of next?
Yeah, so our SDN like routing, application can do a lot of these things, and there is a lot of next hop group modifiers happening as a result of some switch going down or some links flapping at a peer switch or a switch at a different layer.
Yeah, I can give example. I mean, BGP will pick a non-optimal path, will not program it as a multi-hop, and for whatever reason, if the best path available is gone and there are 2 non-optimal paths available, then it will trigger the update for that.
Okay.
So you will end up.
So that's a kind of frequent thing that you observe. Okay.
Yeah. I mean, it happens even in the BGP.
Yeah, but you still probably first, whenever a next hop is no longer valid, the first thing you want to do, right, is to remove it, right? So you won't wait until you get the replacement. You want first to remove. So can you bring back the use case you just showed, Kishore, please?
Can you see it?
Yeah. Let's say in this case, A and B were removed. So in my mind, the first thing you want to do is to remove AB. That's the first thing you want to do, right? Because they're no longer valid. You can't wait for DEF to come because you have traffic coming in, and until you modify the group, you're still sending to A and B, right? So the first thing you'll probably do a delete, okay? And then the next thing you will do, and here, yeah, I agree, it's interesting. You want to add DEF and also update C weight, right? From 1 to 2, okay? But always think that you want the data plane to, as soon as possible, right, to remove the non-valid next hop as soon as possible. And in my mind, then yeah, let's say if you use bulk, you first you do a C edit to 2, and only then you do a bulk add DEF. Yes, it's slower than doing everything, but I think removing A and B would probably have to happen immediately. I'm not sure you can wait, right, to find out if you have a DEF.
Sure,
In a
that's a
real
good observation. Yeah, so sure, I think, you know, fast pruning is probably going to happen first. But yeah, the rest of the, you know, modify adds, you know, still gonna need two steps.
Yes, but you're right. And but even then, let's say you do add DEF and only later you update C. Yeah, it's not optimal. I agree with you. It's not optimal. Okay, but is it, because I think you kind of found something in the side that is not like inline replace. It's not something that is actually really supported from the like crude approach used for the objects. So you're kind of trying to solve, I think, a generic problem, but with a specific solution. I think that's also what Anandi said. And the question is, maybe we need to think on a more generic solution to this problem where you want to say, I don't want to do add separately, delete separately, and set separately. I want to somehow be able to do all three as one operation, right? And your solution was to create a full list and say, now I replace the whole list, right? That's if I'm trying to use.
But Guy, from the rest of the, you know, psi object pipeline, right? The next hop group OID does not change, so the routes do not get modified.
Yeah, of course. Only the
all of
next
that
group
is,
itself, the members is changing. Yes, of course.
yeah. So
Yeah. So I'm saying it is valid, but I think, like I said, the problem is easier because, okay, it's two steps. It's let's say add and then edit to C in this case, right? So, and I personally, I think that you have a real need, but creating two different ways to do one thing, it's
No, Guy, I think you are raising a very good point. This is a very point solution, uh, but I don't know if there's a better solution or how much of a churn we want. Do we want one thing? I was thinking, just bulk of bulks, if that helps.
Yeah, bulk of bulks could be one thing, and another thing, just if we are trying to solve this specific problem, you can modify members, kind of do the algorithmic diff and see that A, B are gone and D, E, F are coming in, and you will actually have bulk set operation where you would change weight of C and change the members next hop ID from A to, let's say, D, and from B to E.
yeah, I think that still leads to two operations. And
yeah, you will have two operations.
And the issue with bulk of bulk is, like, what happens if one of those bulk APIs fails, right? The rollback is, you have, let's say, bulk create, bulk modify. One of those failed. The rollback is going to get very interesting.
That Kishore even remains even in this. You have underneath how SDK invokes these lists, right? May not be in a one shot, right? Maybe actually a set of steps, and any step failed, then we have to figure out a rollback. It's just that it's not exposed to you, but there's still a problem, which a given side after implementation. I think I have to drop the meeting, but probably we need to have another round of discussion.
Yeah, Kishore, one more question. Do you want this operation within an Excel group or also across Excel groups? So to have one cycle and do this in place update for multiple Excel groups with one cycle?
I mean, we are kind of adding a bulk create of next hop groups. So you could potentially send many next hop groups
No,
in
but
one.
is it really needed? Is it a use case?
So I think what we saw while working on performance optimizations is reducing the orc agent to SyncD round trips is like gives us some some improvement. So wherever we can bulk between orc agent and SyncD, we are trying to do it.
By the way, have you looked maybe if it's specific to Sonic? Have you looked at the solutions in Sonic community, like using ZMQ or some?
Yeah, we use ZMQ between orc agent and SyncD.
Okay.
So, but anytime and we use synchronous mode. So anytime you have that, each time orc agent waits for SyncD to respond, bulking is very useful in that amortizing the cost of the call.
Okay, good.
Okay, hey, I think we are over time. So did folks want to have another discussion on this, continue this, or can we do that maybe offline? Okay, so we can probably continue with offline review. If needed, we'll reschedule this if there's more discussion needed. Thanks, Kishore, for presenting this.
Thanks everyone for
Thanks,
the
Kishore.
discussion.
Thanks.
I appreciate it.